Assalamualaikum and hello everyone. My name is Basma. Today we're going to present our chemical product design project, which is the low melting point active ingredients for pesticides. So the team members are me, both of Naim, Charisma, and Noor. So let's start. So for today's presentation, our plan will be presenting the product survey and the business model, product design, which includes the molecular level, and finally the economic analysis. So let's start. As an introduction, pesticides are chemicals used to destroy pests. They are often used to eradicate or manage a wide range of agricultural pests that can harm crops and livestock while reducing farm productivity. Population growth and shrinking arable lands are responsible for maintaining good agricultural practice and increasing use of pesticide products in areas that have been neglected in the past. We have multiple types of pesticides, and here we are mentioning 4 of them. So we have insecticides, responsible for killing insects, herbicides for plants, fungicide for fungi, and bactericides for bacteria. Pesticides present a lot of challenges, such as it has several negative effects on the human body and the environment. They contain toxic chemicals that are released into the environment. Even though each pesticide is designed to kill a specific pest, a large percentage of pesticides end up somewhere other than their intended target, such as the air, the water, sediments, and even our food. So pesticides have been linked to a variety of human health risks, ranging from short-term effects like headaches and nausea to long-term effects like cancer and reproductive harm. So in order to choose the right product, there are some formulation selection consideration that needs to be considered. So a well-considered decision to use the best formulation for a given application will include an examination of the following factors cited here, such as the environmental concerns, the applicator safety, the pest biology, the availability of the equipment, surfaces to be protected, and also the cost. Our product survey requires a market segmentation. So for our case, this time we chose to base our research on 3 segmentations, such as geographic segmentation, economic segmentation, and demographic segmentation. For the first one, areas, population, city, or climate condition are used for geographic segmentation. Increasing the demographics and decreasing the arable lands are responsible for maintaining good agricultural practice and ensure greater use of pesticide products in areas that have been neglected in the past. As for the economic segmentation, the economic sectors considers the income level of the target market. In general, the rich have the opportunity to buy more consumer goods than the low income. Lower class consumers, on the other hand, often pay. Therefore, we target all classes who can enjoy the quality, the innovation, and the functionality, and even social benefits that our products can achieve. As for the demographic segmentation, it is the division of the market into smaller parts based on age, income, occupation, gender, education, ethnicity, religion. It is used to target specific audience. Our product survey also requires to know who are the key players. The agrochemicals market is fragmented, with significant players including the agriculture, chemical, crop protection, Hexstar Group, Advancia, New Farm. New product launches, mergers, and acquisition, and partnership are the major strategies the leading company adopts. These companies are also investing in innovation, collaboration, and expansion to increase their market share. A useful tool for our product survey is the use of the quality function deployment methodology, which is practically suitable for demandful product. Given a set of consumer preferences, the product development team seeks to express them as a product requirements using a more technical language involving quantitative and measurable variable. As we see here, we have a table that summarizes the customer preferences and respective technical requirements. Let's start. As an example, we need the product to be active against pests and control insect infestation. So we're talking about active ingredients. We need the product to smell good. So we have a fragrance concentration. It needs to be soluble in the water. So we need to find a solvent ingredient. It has to be easy to store and higher absorption. So we need it to be in a solid formulation. It needs to be consistent and stable. So we're talking about the surfactant, and especially the product needs to be environmental, safe, and cause no harm for human, which means we need to have non-toxic ingredients. House of quality is part of the quality function deployment methodology that is consisting of 7 blocks, as shown in this figure. We have the first one that contains the consumer preferences, the second that contains the quantitative and measurable technique requirements that correspond to at least one of the consumer preferences. We also have the relationship between the customer and the technical requirements, which are described in correlation metrics, and where the entries represent where the relationship exists between the given consumer preference and the technical requirements. And here it's more quantitatively shown. We have numbers, so 0, we don't have any relationship, 1 is weak, 3 is moderate, and 9 is strong. Here also, in this house of quality, we have the roof, which is the interaction matrix that shows the conflicts and the synergies among the technical requirements. These technical requirements change in the same direction as they are more or less fulfill the requirement. We also have weighting factors for the consumer preferences, as well as the capabilities of the competitors in fulfilling the consumer preference. For each consumer preference, a score is obtained by multiplying the entry in the correlation matrix for the technical requirements under consideration with the correlation weighting factors in that block. So at the end, making a summary of the scores for all the consumers' preferences give the importance weighting for the technical requirement. Here we have the business model Canva, which focus on the product development team's effort on this essential task for developing a successful product. So here, as you can see, we have multiple sections. We have key partners, key activities, key resource, value proposition, customer relationships, channel, customer segment, revenue, and the cost of the structure. As for example, I'm just going to take a few. Here, the value of the proposition that our product has to be affordable, easy to use, easy to mix, safe for the environment, safe for the humans, doesn't cause any irritation for the skin or the eyes. For the key activities, we have distributing, advertising. The resources can be investors, can be the skilled workers, can be the raw material suppliers, the chemical suppliers, the ingredient suppliers, and our supplier partners can also be farmers, the government, the chemical suppliers. The customer segmentation can be the public, can be companies, can be pesticide, herbicide users, the environmental groups. And for the cost structure, we might have like tools, costs, machines, utilities, facilities, the labor cost, the research cost as well. And finally, like the way we can interact with our customer is by social media, by blogs, by digital marketing, also like websites, online retailers.
So moving to the product design. For the problem formulation, in the production of pesticides, the safety and environmental impact of those products have long been of concern to the agrochemical industry. Pesticides is generally used to kill or repel pests of all types, including insects and plants. Pesticide component known as active ingredients having melting point range 41 degree to 55 degrees Celsius, respective to manufacture of pesticide. Problem associated with such formulation including packaging contamination, excessive volatility and use of organic solvent. So it is highly desirable that solid formulation of active ingredients such as water dispersible granule be developed. There are two formulations that are known in this industry. The first is liquid formulation. There are three types of liquid formulation, which are solution, suspension, and emulsion. Solution is made by dissolving a substance into a liquid and cannot be sprayed by filter. Suspension is a mixture of very small solid particles throughout a liquid. Emulsion is a mixture of droplet of one liquid in another liquid. So next is a dry formulation. The active ingredient is on the surface of solid carriers such as the clay and ground corn-cobs. Granules are ready to use formulation. The amount of active ingredient is relatively low. Granular formulation are mostly used to apply chemicals to the soil to control weeds. Moving to the product needs, target properties, and target value for the problem formulation. So, as you can see in this table, we have product needs, active ingredients, volatility, solubility, absorption, biodegradable, and safety. And we have their target properties and target value of each of the product needs. So next is the database for product development. In this table, we have type of chemical which are active ingredients, anti-foaming agent, compatibility agent, buffering agent, extender, softener, wetting agent, and surfactants. So we have function and example and concentration of each of the type of chemicals. So in this mini database, we have specified the type of chemical that we chose. And this is the detail of the chemical, such as the compound structure, molecular weight, melting point, boiling point, and also the water solubility of the chemicals.
Next, we're moving on to the generation of candidate via ICAS. The CAM software is used to generate ester and compound with double bond. The desired number of groups and functional groups are specified in the figure at the right side. The proper properties are restricted in accordance with their values under a non-temperature dependent properties tab, as shown in figure in the left side. The target molecule have a cyclic structure and at most 10 functional groups with a molecular weight between 886.9 and 900 gram per mole. The melting point is set between 406.1 Kelvin to 450 Kelvin to prevent liquid pesticide combination. Next, after executing the design, the CAM program generates 10 candidates, which are shown in summary result in figure. A total of 15,000 chemically viable molecules are developed based on the constraint related to the molecular structure. Out of these, 10 chemical molecules that meet the property requirement are selected and tabulated, along with their labeling and the chemical structure and the target attributes. The result demonstrates that the ProChem software effectively select the best known molecule with practical attribute for the intended product. Hence, out of the 10 chemical compounds generated, 7 were eliminated in the first scanning due to their melting point being outside the design target. The remaining 3 compound 2, 7, and 9 were evaluated further. Chemical compound 9 had a slightly higher lethal dose, LT50, than compound 2 and 7. However, compound 7 had the appropriate melting point for a solid fermented pesticide, and therefore it was chosen as the active ingredient. For the property model estimation section, the group contribution method based on Monero-Gandhi method is applied. The process involves 4 steps. First, identifying the functional group in the chemical compound. Second, determining the number of group of each type. Third, retrieving the necessary parameters for model parameter table. Fourth, summoning the contributions and using the corresponding property model function to estimate the properties. The formula below shown used to calculate predicted melting point and the boiling point that can be seen in the left side of each column. Next, my teammate will continue the presentation.
For the economic analysis based on this statistic by the Department of Statistics of Malaysia, it is shown that the trading of agriculture sectors has been increased in the recent years, indicating the continuous supplies of crops from the market. Therefore, to improve and maintain the quality of the crops exported, the use of pesticide has also been growing, making an ongoing demand. After that, we made a comparison with the competitors in the market. All of these pesticides stated above are considered as competitors as they are pesticides with main ingredients composed of active ingredients. As you can see, Syngenta and Bayer have two products with a higher selling price than our proposed products. Meanwhile, these two brands are well known and have experience in selling pesticide for a long time in the market. So in comparison with all of these products, our product has an advantage in prices as it's much more cheaper and can obtain in a bulk size, which is more accessible to store than in the liquid form. So in short, based on several studies obtained from the internet, our products that focus mainly on ivermectin as an active ingredient are still new in the market but have proven efficiency in removing pests. Next, to estimate our product selling price, before we launch the product, several studies have been done to compare the prices of the existing product in the market. So the way we set our price is through a strategy called penetrating pricing strategy. This strategy stresses on capturing a large customer base, starting with a low initial price at the beginning. So the price can be adjusted based on demands or any market fluctuations. The prices of all ingredients are searched and compared on the internet when deciding the price of our product. So the product is set to be sold at 300 ringgit per unit, where the desired weight will be 1 kg.
Now, I'll be explaining about economic analysis using the project cash flow diagram. But before explaining briefly about the project cash flow diagram, I'd like to present about the estimated cost that has been calculated for each ingredient per kg of pesticide. The total cost for 1 kg of pesticides according to the mass composition has been displayed in the table above, and it was found to be RM 150.47 cents. After finding the cost of ingredients in 1 kg of pesticides, the cost is classified as a variable cost which is under 150.47 cents per unit, where it to be determined the 4,000 units were produced per year, and thus the selling price of the unit are also dependent on the number of units being produced per year, which is 300 per unit. The manufacturing cost was 10,000 for the equipment used to produce the herbicide. Development cost is 1,000 for the development year of 1 year, and operation time for the production of the pesticide was 8 hours per day with the 10 workers involving, and each worker would be 12 ringgit per hour. The net working capital, including the liabilities and assets of the company, was 10,000, and the company has decided to advertise the agriculture pesticide for 9 ringgit per day on Instagram and Facebook platforms, where advertising days will be 10 days per month. Research and development costs was between around 1,000, so the concerned research will be carried out every year. The right side of the table has displayed the depreciation rates for equipment cost going to be used for equipment, so because every year equipment depreciates and the acquisition reduces according to the usage every year. So this is the final process cash flow diagram where all the values has been obtained from the tables that has been shown in the slide before, according to the cost and sales that has been made per unit, and the depreciation was obtained from the depreciation table after tax. The taxes was determined to be 30% of tax with investment rate of return, and the bank tax was set at a rate of 5% as known to be the common bank tax and the minimum bank tax in every bank. To obtain the process cash flow diagram in the slide before, there are a few steps that were followed and considered in this slide. With the sales with selling price multiplied the number of units, fixed cost was due to the annual advertising cost and worker salary, variable cost was cost of ingredients multiplied the number of units sold per year, income from operation was sales deducting cost, depreciation was calculated based on the depreciation table that was showed in the slide on the right side of the slide. Earning before income tax was IFO minus D. Taxes is based on 30% tax of the bank rate, but at a bank rate of 5%. After tax operating income was supposed to be EBIT minus T. EBIT operating cash flow was R plus D. NWC is the net working capital that has been in the company, that is 10,000, and this same net working capital spending was done on the equipments on the year 0, and finally process cash flow diagram was obtained by calculating the total earned and spending on every year starting from the year 1. After all the calculations and tabulation on the table of the process cash flow diagram, the economic analysis based on NPV value set to 0 was carried out to find the investment rate of return. In here, two methods were used. First method was based on the manual method where the R value was calculated using the quantity equation, and method was using the Excel method and interpolation method using trial and error. In both methods, the R value is 6.4 and above, but in method 1, R value is 6.4, whereas method 2, R value is 6.4 and 2, which is more accurate to be accepted for the bank interest rate, where the NPV would be obtained at 0. The second method will carry out to maintain the accuracy of the first method. Therefore, the final R value was to be obtained at 6.412, which is more than 5% of the bank interest rate. That means this project is very viable and economically very feasible to be carried out and very attractive for our herbicide protection. Here, for the paper period, tabulation of data was done for the cumulative cash flow against year, where it was obtained that the total investment of 20,000 gave a positive cash flow after 1.12 years, which shows that the payback period is after 1.12 years.
Moving on to the proposed packaging design, polyethylene terephthalate PET was selected as it is widely used in product packaging for the agricultural industry. PET materials are good in tensile strength, making them very suitable for carrying heavy loads such as fertilizers. PET materials is also cost effective as it is lightweight that allows shipping more quantity at the same price. PET also display a low moisture absorption, which provides a longer shelf life for the product. Fewer losses to pests will lead to an increase in profit margin. Furthermore, PET bags are safer as they are leak-proof, non-reactive, and easy to handle. And as a result, less space is required to store many bags. The bag is in rectangular shape to ease packing. And the reason for choosing green color outer layer is because our products aid in producing higher quality crops.
Assalamualaikum and hi. Now we present the sustainability consideration. In this chapter, we will focus on our active ingredient and also our packaging. And this is the three things that will be discussed in this chapter, which is the sustainability factors, SDG, and also sustainability in the market. Sustainability factors. These are the factors for ivermectin, which is our active ingredient. The factors are first, it is environmental persistent. It is because it depends on the exact circumstances. Ivermectin can linger in the environment for a few weeks to months. Next is effects on non-target species. Ivermectin has the potential to be hazardous to a variety of non-target species, including beneficial insects, birds, and also fish. Next, human health. With the proper precautions, ivermectin is generally regarded as safe for usage in people, although exposure to excessive quantities of the chemical may result in toxicity symptoms such as sustainability factors. These are the factors for ivermectin. Next, sustainability factors are about our packaging, which is the polyethylene terephthalate (PET). The factors are first, it is recycled. PET is a material that can be easily processed to create new items such as bottles and containers, and is highly recyclable. It can also be manufactured into fibers for clothes and textiles. Second, it is an energy efficient. PET is a lightweight polymer that lowers the cost of shipping and the energy needed to move goods. PET recycling requires less energy than the manufacture of fresh plastic from virgin ingredients. And lastly, it is durable. The overall environmental impact of packing materials can be decreased by using PET. Next, sustainability factors are about our packaging, which is the polyethylene Sustainable Development Goals (SDG). For ivermectin, there are two SDG that involve, which are SDG 12 and SDG 17. SDG 12, responsible consumption and production. Ivermectin and the other chemical pesticides can harm the environment by contaminating the soil and water. We can encourage sustainable consumption and production habits by minimizing the usage of these pesticides and supporting other management strategies. Next is SDG 17, which is the partnerships for the goals. Ivermectin can collaborate between farmers, researchers, policymakers, and other stakeholders. We may collaborate to accomplish sustainable development objectives connected sustainable development goals (SDG). For ivermectin, sustainable development goals for our packaging, which is the PET. The two SDG that involve are SDG 14, life below water, and also SDG 15, life on land. For SDG 14, life below water, ocean, sea, and marine resources should be preserved and used sustainably for sustainable development. The impact of plastic pollution on marine life can be lessened with the correct disposal of PET packaging. Next is the SDG 15, life on land. Forests, marshes, mountains, and other terrestrial ecosystems are among those that life on land seeks to maintain, restore, and promote via sustainable use. PET packaging should be disposed of properly to minimize litter and the harm. Sustainable development goals for our packaging, which is the PET. Next is sustainability in the market. How ivermectin will sustain in the market. First is resistant management. By employing a variety of pest control strategies, including the usage of ivermectin, we can lessen the emergence of resistance in the target species, enhancing the long-term efficacy of chemical pesticides. Second, ivermectin can be involved in research and development by developing and promoting alternative control approaches like biopesticides. Next is sustainability in the market. Sustainability in the market. How PET will sustain in the market? First, by recycling, lowering waste And conserving resources. Increasing the recycling rate of PET packaging may make it more appealing to customers and companies that care about the sustainability of the environment. And second is innovation. To increase the sustainability of PET packaging and increase its appeal to customers and businesses by creating new technologies, materials, and designs.